NAT gateway is AWS managed service. So naturally it comes with the scalability, availability, and a very minimal administrative, other than provisioning and occasional route updates. There is very less we have to do in terms of managing this. So NAT gateway is again something that we do not specifically provision as an instance, but it's rather creating as a service entry that we normally create within AWS services. So it's very simple to create, and it's not like an instance like an NAT instance. So that's the fundamental difference. In terms of the network bandwidth, by default, it starts with 5 Gbps and it can scale up to 45. But in case if we are exceeding that, and then we need to consider splitting up our subnets and distributing the workloads to different subnets. And probably we need to configure multiple NAT gateways across the subnet if the requirement for network bandwidth increases. They need to be assigned with elastic IP address. So this is a mandatory requirement. In terms of cost, there is no cost to elastic IP address if you are using them. But if you are just reserving them and not using them, there is a very minimal charge, like $0.01 or something like that per month or so, even though the charge is minimal. So usually it's free if you are using it actively. Cost for NAT gateway is they are charged depending upon the number of NAT gateways you use. Again, very similar to the instances. The duration of usage and the amount of data you send through the NAT gateways. So they support primarily TCP, UDP, and ICMP protocols. And as I mentioned before, they cannot be used. But for example, if you're having a NAT gateway here, no instances from this subnet would be able to use this gateway. So that's the difference between the instance and the gateway. Instance would allow the source subnet to be able to use them as well, whereas the gateway will not allow them.
Is there any reason why the gateways don't allow it, or is it just the feature of it?
It's just a feature of it, really.
Yeah, thanks.
I think the recommendation for them is to segregate network accordingly.
Okay.
So you have a specialized network focusing on, for network purposes, storage purposes. And so rather than clumping up everything in one subnet and trying to do multiple things in a single subnet, which is not very conducive for the network itself. So I think that's more around the good practices side of things.
Okay.
What we are going to do is create a private subnet. So we have a private subnet. We are going to create a NAT instance and place it within our public subnet. And then we're going to launch an instance within the private subnet. First, we are going to try and see if we can connect from the internet to the private subnet. If that is not possible, then we will first connect to our public instance. And then from there, we will connect to our private instance. So that's first task. The second task is we will try and see if we can connect from the private instance to the internet via both gateway as well as from the instance. So that's the NAT gateway or the NAT instance. So that's what we're going to look at today. I guess we have already created the private subnet. So we have already created this part here. So next we need a route table as well, right? Let's create that for the private subnet. So we had the default route table, which came with the default VPC when the account gets created. And on the other day, when we created the public subnet, it created the public route table. Now we need to create a private route table. Let's create a private route table. The VPC we need to use is another private VPC we have created. So we have now a private route table. Let's see what's the routes we have. Okay. So any traffic within the CIDR range, it will be directed locally. So which means within this CIDR range, any traffic, source or destination, it will be redirected internally within this network. So that's the meaning of this route. Okay, so we've now got a private subnet. We have got a private route table. Let's associate the private route table with the private subnet that we created. Let's look at the subnet. So if we look at the route table, when you do not specifically associate a route table to a subnet, it will automatically look up for the default route table and it will try to associate with it, and it automatically gets indirectly associated with it. So what we have to do now is to edit this so that it gets specifically associated with the private route table. So now you can see the only local traffic is allowed as per our route table. So we have created the private subnet. We have created a private route table. We have associated the route table to the private subnet. So the next task is to launch the NAT instance into the public subnet. Let's create a new instance. So here we have to do a quick search for NAT. So again, there would be few NAT instances available in AWS marketplaces as well as the communities as well. So let's use the community AMI. The first one is a test one. Let's not mess around with this. Let's use the second one. Seems to be more stable. Yeah, standard one. Again, you can pick and choose the type of instance depending upon your requirement and throughput needed. We're going to stick with the standard one. So again, number of instances, just one. So network, we need to choose the private network. Subnet, we can choose either one, but it needs to be placed within the public subnet. I think to the question that was asked before, you can see clearly here, the NAT instance that we are going to create is going to be placed within the public subnet, which is here. That's it. We don't have to change anything else. So again, it will get an automatically assigned public IP because when we created the public subnet here, we defined the property that allows any instances created within this subnet to be assigned with a public IP. So this will automatically get a public IP. And as we looked before, it needs to have either a public IP or an elastic IP. So just the public IP should be sufficient in our case. So let me continue to storage. Then tag, let's add new instance. Okay, so here we have to edit a few things within the security group. So as you can recall from the security, can someone tell me what a security group is used for? With respect to that particular instance, so security group determines what comes in and goes out, the interaction between that instance and any other network connectivity, basically. So we are configuring a NAT instance here, right? So we are now launching a NAT instance. And what we have to let that instance know that any traffic from here, this CIDR group, related to HTTPS, ICMP, whatever, to be allowed to pass through. So we need to define that in this instance. So the best way to do it through the security group. Let's allow the HTTP traffic. We don't want everyone to be able to access it. We want a specific subnet to be allowed. And in this case, it is 10.0.2.0/24. So that is our private subnet. Same thing for HTTPS traffic as well. Okay, so that's it. We're not doing much. Let's launch. So we need to download a key pair. Let's create a new key pair. NAT key.